section 1-7. We're going to be solving absolute value equations. This is the last section for the chapter, so first and foremost, enjoy that. Second part of it, we shortened it, so happy end of chapter 1 to you guys. What we want to do is look at absolute values, and I want to go back first and foremost into what an absolute value is, because I got to be honest. I think we have a general idea of what it looks like, but I'm not quite sure we really get the definition of it, okay? So let's talk about absolute value. Absolute value of a number is written with 2 vertical bars, okay? And what it means is it's a distance, okay? It's a distance between the number 0 and that number. And here's how it works. I want to show it to you in picture form so that you get an idea. Now let's talk about distance first and foremost. The number one thing that I think you guys remember about absolute value is that absolute value turns things positive. And I agree with that, and I'm glad you remember that, but I got to know why. And if we keep in mind that distance is always positive, then I think we'll be able to remember it talks about a distance. It's actually a graphical representation. Okay, so take a look. I just want to show you a couple of these, but take a look at part A. And I'm going to draw my number line kind of up here out of the way. If I want to know the absolute value of 6, on my number line I have to have a 0. Well, 6 is over here. And the question is, how many units away from 0 is it? Well, if I count 1, 2, 3, 4, 5, 6, then my absolute value is 6 because it's 6 units away. And that's what an absolute value means. It is a distance away from 0. So what's the absolute value of 0? Well, I'm not moving anywhere, so the distance is 0, I'm there. What about negative 6? Well, if I extended my number line in the other direction and hit negative 6, again, my distance would be 6. It's just in a different direction. But the thing is, we don't account for direction. We account for how many places you have to move. Okay? So, now, let's talk about operations with the absolute value. The absolute value acts as if it were a grouping symbol or a parenthesis. So you do those first. Okay? So I go inside. Negative 6 plus 3 is negative 3. Now I take the absolute value of negative 3. Negative 3 is 3 units away from 0. If I look at E, negative 6 is 6 units away from 0. 3 is 3 units away from 0. And if I add those together, I get 9. Now you'll notice a difference. You do the absolute value signs once you've worked inside the absolute value. Last one. The absolute value of negative 5, the distance away is 5, so I'm going to multiply that by 4. The absolute value of 2 is 2, so I'm going to multiply that by 6. Well, 4 times 5 is 20, minus 6 times 2 is 12, therefore my answer is 8. Okay? And so that's kind of the idea. Absolute value works very similarly to parentheses. We just need to talk about a distance, so a positive value. Extraneous solutions are solutions that do not work when you plug them back in, and we say they must be either eliminated or discarded or gotten rid of. We need to just basically forget about them. So here's what happens. We're going to look at a couple of things. I want to graph the absolute value of 3, and the question is, at what places, here's what we're actually asking, at what places on a number line is the distance away from 0 equal to whatever number they give us? So here's what this is asking. At what places on a number line is the distance away from 0 going to be 3? Well, let's draw a number line. Here's my 0. I could go 3 in the negative direction. 1, 2, 3. What number am I at here? Well, I'm at negative 3. I could go 3 units in the positive direction, and where am I right here? Positive 3. Therefore, my two solutions are x equals -3, or, because they're separate, x equals +3. Now, you're saying, wait a second, every other time we've solved an equation, we've only gotten one solution. Because absolute value is a distance, we are going to have two solutions because you can go to the left and you can go to the right. Okay? Now, let's talk about the second one. If I'm at 0, the question is, what are my two solutions to get where I'm 0 units away from it? You're probably looking at me going, really, Ms. Shavanik? I mean, come on. Well, if I'm not counting anything to the right, it's 0, right? And couldn't I say in the positive direction or in the negative direction? I mean, could I say that? Now, to me, this looks absolutely absurd. Do you need to say -0? No, there is no such thing as a +0 or a -0. It's a neutral value. So I don't really need a second second equation if it's really the same thing. So in this case, because I'm not moving both left and right, there is only one solution. Last but not least in this section, as you take a look, we are asking, where are you that the distance away is -3? The answer to this is not possible, because distances can never be negative. Okay, I can never have a negative distance. Okay, so keep that in mind. Now, I want to solve some inequalities, so I'm going to move this up. And I've got the rules kind of down here, and I want to look at it. Here's what we're saying, okay? That if I look at the center, where the center is kind of in the middle of the absolute value, the question is, if I'm at 5, what numbers do I have to be at to be 2 units away? Okay, so let me try and explain this here. This is going to be my center number. I don't know if that's the way to say it, but I'm going to say that. This is how many units away. Now let's talk about units away. So I'm going to look at my number line. Okay, I know I've got to have a 5 somewhere here. Okay, if I say 2 units away, I could go 2 in the positive direction. So I'm going to say that x minus 5 could be a +2. But I also could go 2 in the negative direction. So here's the positive direction. But I also could go 2 in the negative direction. That means I need it to equal -2. And so what we're going to do when we're solving an equation is we're going to look in both directions. We're going to drop the absolute value, because when I drop the absolute value, I can make 2 equations that account for both possibilities, because we know absolute values have to have 2 possibilities. Now let's look in terms of number line, and then we'll make our algebra work with that. If I go 2 in the positive direction, I'm at 7. If I go 2 in the negative direction, I'm at 3. So my solutions are x equals 7 and x equals 3. I'm going to put a big or because they are separate. That goes back to 1/6. Okay, how does that work? Well, if I'm in the positive direction, I solve this equation. I add 5 to both sides, therefore x equals 7. If I'm in the negative direction, I make the 2 negative, and I add 5 to both sides, and 5 plus -2 is 3. Okay? What that means in terms of this, reading this, is that the solutions that I get are 2 units away from the center number, that's 5. So let me give you just another brief one to see if we know what that means. If I ask you this, x plus 14, the absolute value of that equals 7. Now, we always do in this x minus our number, okay? So if it's already a plus, that means our number has to be negative. So as we go through, the center will be at negative 14, and my distance away is 7 in both directions. So the two equations I would use is x plus 14 equals 7 and x plus 14 equals negative 7 to account for both directions. This is the idea of what we're doing. Now, some of the time you're going to plug this back in and it's not going to work. We're going to look at an equation that just absolutely doesn't make sense. And I'm going to show you that. But what I wanted to say is at least what does it mean in terms of a number line, because we kind of need to know what we're talking about. Okay? So, last two examples. You know what? I'm going to change the thickness of my pen here a minute, if possible. I'm going to write a lot. There we go. Okay, here we go. I'm going to do 6 first, because I think 6 is what we're used to seeing with just a number on the end here, and then we'll come back. What this says is I take my first equation, so I have 2x plus 9, it equals 20. This is saying it's 20 units away from wherever the center is in the positive direction, or I could go 20 units away in the negative direction. Okay? So that's what they're talking about. Now, let's solve. If I subtract 9, 2x equals 11. If I divide by 2, I'm actually going to make this a decimal just because I need to know where in the world that is. Let's get my math right. Sorry, guys. You're probably looking at me going, really, Miss Spanik? Okay, 5.5. Let's do the other one. I'm going to take the same procedure, and here's the one thing I love about it. It's exactly the same. I've got negative 29. When I divide by 2, x equals a negative 15 would be 30, so 14.5. So I have this as a solution or this as a solution. Now, I don't know that that's right, and I just circled it. That was probably a really bad idea. So let's check this, because whenever you have an absolute value, you could potentially have an incorrect answer. So let's double check this. If I take the absolute value of 2 times 5.5 plus 9, the question is, do I get 20? Well, we said do all of this inside. You know what you get? The absolute value of 20. Does that equal 20? The answer is yes, so this is an okay answer. Let's try the other one. If I take 2 times negative 14.5 and I add 9, do I get 20? Well, inside I get negative 20, but I take the absolute value. Is the distance from 0 to negative 20 going to be 20? Yes, because this also works. Guess what? They both are solutions. And this is what we mean by checking for extraneous solutions. If I plug my number back in and once I take the absolute value it doesn't work, then it's considered an extraneous solution. Okay? Let me change the color so that as you can see, if in case I need to go over. Let's do one more. It's the same idea. We're going to set up our equation as 4x plus 10 equals a positive 6x, so in the positive direction. We also want to solve when 4x plus 10 goes in the negative 6x direction. And that seems weird to say in the 6x direction, but just go with me for right now. Okay, let's solve. I'm going to move the 4x this time because I already have an x over there. So I have that 10 equals 2x when I divide by 2, we're saying right now that x is 5. And then I have a big fat or in the middle because they're two separate answers. Let's do it again. If I subtract 4x, 10 equals negative 10x. So I divide by 10, x equals negative 1. All right, here's my goal. Before I circle them, since I did that prematurely earlier, let's check these. If I take this absolute value, now here's the problem. You have 2 x's in your original equation, which means you're going to plug it in twice. So I take 4 times 5 and add it to 10. And the question is, do you get the same thing as 6 times 5? Well, let's check her out. 4 times 5 is 20. 20 plus 10 is 30. Is the absolute value of 30 equal to 30? Yup, guess what? I'm circling it. Okay, let's try the second one. Is 4 times negative 1 plus 10 the same thing as 6 times negative 1? Now you're noticing I'm going back to the original 6x, not the negative. That's important. You always check the original. Well, 4 times negative 1 is negative 4. Negative 4 plus 10 is 6. Is the absolute value of 6 equal to negative 6? The answer is absolutely not, because the absolute value gives me a positive answer. This is called an extraneous solution. Let me give you a hint that normally occurs when a variable is on the right-hand side. Okay? Now, we're going to be solving this, but whatever you do, make a note. Absolute value equals 2 equations. Okay? Absolute value equals 2 equations all the time. Hey guys, that's the end of chapter 1. Thanks for watching. In class, we will practice this some more. We'll probably do some whiteboards, things like that. But you are officially done with videos for chapter 1.